So we have seen this representation of RNN, right? This is how RNN works. We have seen that we have the layer of neurons here, and same layer unfolds over time. One same layer unfolds over time. This is O2, O3, and when we don't have don't have any word left, we produce the output. This was xi1, xi2, and xi3. So this is O3. Now weights here are W1, W1, W1. Weights here are W2, W2, and the weight here is W3. And when we don't have any word left, we give this O3 to this activation unit here, and we get yi hat, right? And this is O0. So that is how this RNN works. Now the same layer unfolds over time. This was t is equal to 1, t is equal to 2, t is equal to 3. And you see this yi hat is dependent on all of these words, this one, this one, this one. So we are maintaining or retaining the sequence information. So that's the crux of RNN, right? Now I can represent this RNN by using a box, right? So that is called as box representation of this RNN. So what is that? So let's see, I have this. So I can represent this RNN by using this box. So here we are giving the word xi at time t, right? And this word is getting concatenated, or not concatenated, but added with the output from previous time step, that is ot minus 1, right? So this is output of this previous step in time t minus 1. So this is at time t. We are at time t, right? Time equal to t, right? Time equal to t now. So this is output coming from previous step at time t minus 1. And then on this, of course, we have here weight matrix, weight W1 here, W2 here, right? And on this, we are applying the activation function F. We are applying the activation function F, and this is producing the output yi hat, not yi hat, but OT here, right? Output of this step OT. This activation function applied on this is producing output OT. So let me represent this by using a box here. So box, right? So we are applying this activation function on this, right? And we are getting output as OT of this layer. This OT is the output of this layer. And if this is the last word, when this is the last word, we are applying another activation function, G, right? On this OT, we are applying another activation function G on this OT. Let me write it clearly. G, right? On this OT, and we are getting output yi hat, right? So this is the box representation of this RNN, right? So here weight is W3, right? So this activation function is being applied on this this sum of this output from previous layer and this weight, and input to this step is this word, right? So that is how we can represent the RNN by using box. So this is useful in when we'll discuss LSTM, right? So this representation will be useful. That's why I showed it here.